Hi everyone, welcome back to Mathematics for Engineering 3. Today is the fifth chapter of the module and it's going to be the last chapter. Okay, and this chapter is about series solutions to differential equations. Okay, so it's basically how to solve the second order differential equations by using a technique that allows you to write the solutions in terms of power series. Okay, we'll talk about that in details later. Okay, but today is going to be the introduction to the chapter. So let's start. This is the outline of the chapter. First, I'll talk about the introduction, and then the ordinary versus the singular points. Okay, what are ordinary points? What are singular points? And we're gonna talk about that because we need them later on in the chapter. Next, we will talk about the solution near an ordinary point. Okay, that's why we need to know what ordinary points are, because in the third section we're going to be talking about the solution near an ordinary point, and in that section we have two cases. The first case is when the ordinary point is x equals 0. Okay, when the point is x equals 0. And the other case is when x equals any other numbers but not 0. X might be 2, 3, minus 1, minus 2, but not 0. Okay, and in the fourth section, we're going to be talking about the solution near a regular singular point. Okay, so first, we're going to be talking about the, regular versus irregular singular points. Okay, in section 2, we talked about the difference between the ordinary and singular points. And for singular points, they can be classified into regular and irregular. Okay, and we're gonna talk about that. What are regular and what are not regular, so-called irregular. And 4.2, we're gonna talk about the initial equation roots. When the roots differ by non-integers. Okay, by non-integer. And 4.3 is going to be when the initial equation roots differ by an integer. Okay, you don't need to worry about 4.2 and 4.3 at the moment, because right now you don't really know what initial equation roots are, right? Okay, but I just leave it here so that when we complete the whole section and you want to come back and look at what you have learned, so you can look here, so all the topics that will be in the exam. Okay, so first let's talk about the introduction. The introduction from calculus, you know that a power series is an infinite series of the form, this form. Okay, so basically you have the coefficients, right, which are called a1, a0, a1, a2 until an, and until a infinity, right? It goes to infinity, as you can see here. It's from 0 to infinity. And then you have x minus x0. Guys, this x0 is number. Okay, it's number. It may be 5, it may be 2, it may be 3, it may be 0. But it's just a number. Okay, to the n. This is called a power series in x minus 0. Okay, it's in x minus 0. Sorry, x minus x0. Okay, and if you want to look at this as an easier form, but harder to write, it would be this form. Okay, basically you begin with n equals 0. So when n is 0, you get a0, right? And x minus x0 to the 0, and that is 1. That's why you have only a equals 0, a0 here. And when n is 1, you get a1. X minus x0 to the 1. and which is this, this term, and so on. You get a2x minus 0 squared, a3x minus x0 cubed, a4x minus x0 to the 4, blah blah blah, right? And we call a0, a0, a1, a2, a3, blah blah blah, coefficients, okay, which are constants. Okay, so these a's are called coefficients. And x0 is also a constant as well, and it's called a center. Okay, it's called a center. And x is a variable. Okay, x is just a variable. Okay, for example, you can look at these series. For example, the first one is a power series when an is 1 over n, 1 over 2 to the n, right? Which is this form. Okay, and the center here, x0 is actually 2. Okay, that is the center. Good. Here, the second one, it's a power series as well, and an is 1 for all n, because it's actually, it has 1 here, so it's 1x to the n. Okay, and the center is 0, right? Because this series actually summation n from 0 to infinity, 1x minus 0 to the n. It's the same thing. That's why we have that x0 is 0 and an is 1 for all n's. Okay, and that's pretty simple, right? So right now we haven't talked about the differential equations yet. We just talked about the power series, okay, and what they are. Okay, next I'll talk about the properties of power series. Okay, so if you have two summations, which are this summation and this summation, okay, you have two series. Basically, you have two series. You can you can take the sum out. And then you get the the sum or the subtraction of anything an, bn. For example, if you have summation n to n from 0 to infinity of x to the n, plus summation n equal n from 0 to infinity 3x to the n. In that case, it's going to be summation n 0 to infinity. Okay, so you take the summation and then you take the sum, because here right now is the sum, right? It's the sum. So you take the sum of x to the n and 3x to the n, so you get 4x to the n, and they are the same. Okay, so if you have the first series plus the second series, you can take it as one series, and you take an xn plus bn x to the n. Okay, and if you have the first series minus the second series, you can take it as one series. Okay, but you take an minus bn x to the n. Good. The second property is quite easy. You can take a constant out of the series. Okay, for example, summation n from 0 to infinity of 3x to the n is the same as 3 summation n from 0 to infinity of x to the n. That's quite simple. You just take the constant out. Third, this one is very important. You need to know it. It's quite important. Summation n from 0 to infinity an x to the n is 0 if and only if all the a's are 0. Okay, and this just means that a0 is 0, a1 is 0, a2 is 0, and all the a's are 0. Okay, so if sum an x to the n is 0, it means that all the coefficients are 0. Okay, Third, if you take the summation from 0 to infinity, a n x to the n, you can, rearrange, you can, shift, basically you can shift the index from n equals k to infinity, and then you need to shift this to n minus k, For example, if k is 5, you begin from summation. Okay, let me write it here. Summation n from 5 to infinity. Okay, you need to take a n minus 5 x to the n minus 5, and that is going to be the same as summation n from 0 to infinity a n x to the n. Why? Because if n is 5, here is going to be a0 x to the 0, a0 x to the 0. See? If n is 6, the second term is when n is 6, so you're going to get a1 x to the 1. And here the second term you would get a1 x to the 1 as well. See? So they are the same. Good. So it means that you can, shift the index from 0 to k, but you need to change n to n minus k. Good. The fifth property is that you can, just split the summation. It shouldn't be the property, okay? But I put it here because we use it quite a lot. In this chapter. That's why I put it here. If you have summation n from 0 to infinity, a n x to the n, it means that you have a0 x to the 0, a1 x to the 1, a2 x to the 2, a3 x to the 3, blah 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 until ak x to the k, right? And then, it's the infinite. It's infinite sum, right? So you need to take the sum to infinity. So you can stop here, and then you take the sum from n equals k plus 1 to infinity. For example, you can write summation n from 0 to infinity of 2x to the n. Okay, sorry, let's say nx to the n. That would be 0 plus, when n is 0, nx to the n is 0, right? And then it's 1x to the 1 plus 2x to the 2 plus 3x to the 3. And then I want to stop here. I'm too lazy to write further, so I can write it as summation n from 4 to infinity nx to the n. Okay, I can just stop here. Okay, so basically, for one series, I can take some of them out, and then I, keep the rest there. Is that good? Okay, and that is the property of power series. Okay, guys, again, we haven't talked about the differential equations yet. Okay, we're gonna talk about that soon. This chapter's goal, the goal of this chapter, what we really need in this chapter. So in this section, we consider a second order differential equation of the form. So it's in this form, okay? You have y double prime, you have y prime, and then you have y. And the coefficients of y double prime, y prime, and y, they are functions of x. See, these or b's, they are functions of x. Good. Okay, so right now in this chapter, we're going to be looking at this form, and you may know that, for some b, right now b2, b1, and b0, they are functions of x, right? Then it might be x, it might be just numbers, right? And we know how to solve some of them in chapter 1, right? If they fit, some of our forms in chapter 1. For example, if it fits, it's some if it's separable, if it fits some one of the 7 methods. But in this chapter, we're going to be looking at another technique that we can use particularly to solve this equation. And in chapter 1, we know that it is not always solvable, right? Because if it doesn't fit any of the forms in chapter 1, it's not solvable in chapter 1 using the techniques in chapter 1. So in this section, we're going to show that the solution of this equation, the solution of the second order differential equation in this form can be written as a power series depending on the conditions on B2, B1, and B0. Okay, so to sum it up, in this section, we're going to be talking about, we're going to be looking at this particular form of differential equation. And then depending on, B0, B1, B2, we're going to show that you can write down the solution, but it's not analytical. You don't get y equals something. You don't get that. But you get y in terms of power series, which is the, infinite sums that we just talked about. Okay. And that's it, guys, for the introduction. So for the introduction, I just brush up some properties of the power series, right? You learn that from calculus, but I just give you some brush up. And then I talked about the goal of this chapter, which is to solve the differential equation second order in that form. Okay, and in the next video, we're gonna be looking at the conditions, right? I just told you guys that the solutions are dependent on the conditions of B0, B1, and B2, right? And we're gonna have special names for some conditions. For example, ordinary points, singular points, and some those points. So we're going to be looking at the ordinary points versus the singular points in the next video. Okay, guys, so see you in the next video soon. Bye bye.